Welcome to week 3. By now you already done the hard part most engineers rush through. You stepped into an unfamiliar system, made sense of it, and improved its clarity so the next person can move faster. Now we do the part that determines whether this codebase is just workable or actually dependable. Because real engineering is not about getting the change to comply. It's about being able to change the system repeatedly without fear, without regression, and without slowly turning every release into a gamble. So this week, we start building confidence on purpose. We begin by writing tests for code that already exists, turning the system's behavior into something we can prove, not just assume. Then we use these tests as guidelines while we refactor messy parts of the codebase step by step, keeping behavior stable as structure improves. And finally, we add basic automations so these checks run consistently and constantly, even when humans forget. Week 3 is where the system stops relying on memory and intuition and starts relying on discipline. Let's harden it. Hi, I'm Luka Anicin and I'll be guiding you through this module. A lot of teams move slowly for the same reason. They don't trust their own systems. Not because they lack skill, but because every change feels like it could trigger something unexpected in the wrong place. When confidence is missing, shipping becomes stressful, reviews become defensive, and even small improvements start feeling risky. This week is about removing that uncertainty in a particular way. Confidence in a codebase is not optimism, it's evidence. It's knowing that when you change something, you have a reliable way to confirm what stays stable, what shifted, and whether the system still behaves the same way it should. That's what allows teams to move fast without gambling. And this means even more in AI-assisted workflows. AI can accelerate outputs, but it cannot guarantee safety. Safety has to be engineered into the process. So we build confidence through a sequence that reinforces itself. Test, then test-driven development or TDD, then disciplined refactoring, and finally automation to keep the whole thing consistent. We start with the testing not as an abstract idea, but as a practical tool you use every single day. You write tests for code that already exists, which is exactly what engineers do in the real work as well. You're not testing something you designed from scratch. You're testing behavior that already lives in the system, with assumptions that might not be written down anywhere. AI helps here by speeding up the exploration process. It can suggest edge cases, map scenarios you might miss, and help you translate messy behavior into clear assertions. But the responsibility stays with you, because tests are not just a task. They are a contract. They define what the system promises to do. Once those promises are written down, the systems become safer to change in the long run. Then we shift into test-driven development, or TDD. The value of TDD here is not ideology, it's a constraint. When you write tests first, you define or expected behavior before implementation. That gives AI clear boundaries to work inside, which is exactly what prevents it from generating plausible code that drifts away from the intent that originally set. Instead of asking AI to build the feature, you define what correct behavior looks like, and then use AI to help implement that behavior. It becomes an engineering process, not a guessing game. TDD also forces you to think clearly before writing code, which makes your own decisions sharper and your reviews easier to defend. After that, we handle a situation every team runs into. Someone else worked on the code in the meantime. The new functionality works, but the code is messy, inconsistent, and harder to reason about than it needs to be. This is where refactoring comes in. And yes, AI can refactor quickly, but speed is not the goal. The goal is preserving behavior while improving structure. So we do it carefully. We'll refactor step by step, using tests as the guidelines, you'll keep behavior unchanged while improving readability, consistency, and maintainability. The focus here is not cleverness, it's discipline. Every refactor should be explainable, and every change should be safe. This is how you improve quality without introducing risk into your systems. Finally, we introduce basic automation. Not to deploy anything, and not to build heavy infrastructure, but to make sure that quality checks run automatically. Because the fastest way to lose confidence again is to rely on memory and manual steps. AI can help scaffold the test pipelines and simple CI workflows so checks happen consistently, even when humans forget. Automation here is a safety net. It keeps standards consistent as the systems evolve. By the end of week 3, the goal is simple. You should feel comfortable making changes to the new system without fear. Not because nothing can break, but because you build the support structure that make this change safe. You'll know how to lean on tests to validate behavior, refactoring to improve quality without regression, and automation to keep checks consistent over time. Week 3 is about turning judgment into a habit, until confidence stops being a feeling and becomes part of the workflow. When you're ready, open the repository from the end of the week 2 and let's start hardening the system.
Code faster. Build smarter. Lead the future of AI. Join the Advanced AI Engineer certification. Check out our website